The supernova explosion is the most dramatic death any star can have. Sit tight, it's gonna get really exciting. I'm Shweta from Astronera and I welcome you to our course, The Star Stuff. We discussed in the last lecture how the stars evolve and the ones having low mass die a colorful death as a planetary nebula. In this lecture, let's find out how the high mass stars explode and become supernovae. The high mass star undergoes an extended sequence of nuclear reactions in its core and also shells. In the last stages of its life, the sequence of nuclear reactions in the iron-rich core of the high mass star stops. It stops because the formation of elements heavier than iron requires an input of energy rather than causing it to release. The star with high mass dies a violent death. Its core collapses and most of the matter is ejected into the space at high speeds. The star suddenly becomes extremely luminous, and this is what we call a supernova. Astronomers discover dozens of supernovae in the distant galaxies every year. But not all the supernovae are the result of massive stars dying violently. There are different types of supernovae. The differing spectral lines of the supernovae made us realize this. Supernovae with hydrogen emission lines are called as type 2 supernovae. These are core collapse supernovae. When a shock wave breaks out of the star, a portion of the explosive energy escapes in a torrent of light. This is specifically what we call the core collapse supernovae. They have a lot of hydrogen in their atmosphere when the star explodes. The hydrogen atoms then get excited and then they glow. So we observe the hydrogen emission lines in these type 2 supernovae. Hydrogen lines are missing from the spectrum of type 1 supernovae. This type is further divided into three subcategories. Type 1a supernovae have spectra that include a strong absorption line of ionized silicon. Type 1b and 1c supernovae both lack the ionized silicon line. The difference between them is that type 1b supernovae have a strong helium absorption line, which type 1c supernovae do not have. Astronomers suspect that just like type 2 supernovae, type 1b and 1c are also caused by core collapse of the massive dying star. However, the star strips off their outer layers before they explode and become supernovae. Is that it? Is that the end of the life of star? Absolutely not. Hop on to the next lecture and find out.